In this episode, we start by looking at a moment that sounds simple, but is actually one of the riskiest parts of any technology effort, the point where a new or changed system is about to go live. A system can look polished in demonstrations, pass a few checks, and still fail badly when real users, real data, and real business timing are involved. That is why system readiness and implementation testing matter so much in the Certified Information Systems Auditor (CISA) world. These ideas help answer a basic but powerful question. Is this system truly prepared to support the business in a dependable, secure, and controlled way? For a new learner, it helps to think of readiness as the overall state of preparation, while testing is the evidence-gathering process that helps prove whether that preparation is real. One is the condition we want to reach, and the other is one of the main ways we measure it. When those two ideas work together, organizations reduce surprises, protect business operations, and make smarter decisions about whether to proceed, delay, or stop an implementation. Before we continue, a quick note. This audio course is a companion to our Course Companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. System readiness means more than having software that turns on and produces the expected screen. A system is considered ready when the technology, the people, the data, the support processes, and the control environment are all prepared for real-world use. That includes whether the infrastructure is available, whether user access is set up correctly, whether support teams know what to do, whether procedures exist for problems, and whether the business understands how the system will actually be used. Many beginners assume readiness is a technical issue owned only by developers or engineers, but that is too narrow. Readiness is really a business condition with technical parts inside it, because the purpose of the system is not to exist, but to help the organization operate. If payroll runs late, customer orders fail, or reporting becomes inaccurate, the business feels the impact whether the code was elegant or not. That is why readiness includes training, documentation, support coverage, data quality, security controls, and even communication with the people who will rely on the system on day one. Implementation testing is the structured process used to discover whether the system behaves as expected under defined conditions before it is fully released into normal operations. At a high level, testing asks whether the system does what it should do, avoids doing what it should not do, and continues to perform acceptably when conditions become less than perfect. This includes confirming that business requirements are met, errors are handled properly, interfaces work, users can perform their duties, and controls operate the way management expects. A useful beginner mindset is to see testing not as an attempt to prove the project team is smart, but as an attempt to reveal weaknesses early enough to fix them at lower cost and lower risk. Good testing creates confidence, but it does not create false comfort. If a test is poorly designed, uses unrealistic data, or skips important scenarios, the final result may look positive while hiding real risk. That is one reason auditors care deeply not only that testing happened, but that it was planned, documented, executed, reviewed, and connected to actual business and control requirements. One of the biggest misunderstandings about testing is the belief that there is just one test phase and one final answer. In reality, organizations often use several kinds of testing, each with a different purpose, and together they help paint a fuller picture of readiness. Unit testing usually focuses on small pieces of code or logic, while integration testing checks whether different parts work together as intended. System testing takes a broader view of the whole solution, and user acceptance testing asks whether the finished result meets business needs in practical terms. There may also be performance testing, security testing, regression testing, and recovery testing, depending on the risk and complexity of the change. For a new learner, the key idea is that each type of test examines the system from a different angle, like checking a bridge for weight, wind, traffic flow, and long-term durability instead of only confirming that it stands upright. A system that passes one kind of testing may still fail another, which is why readiness depends on coverage, not just activity. Business requirements play a central role because testing without clear requirements is like grading an exam without knowing the questions. The system must be judged against something specific, and that something is usually a set of approved business, functional, technical, and control requirements. If the organization says a system must restrict access based on job role, preserve data accuracy, produce audit trails, and support end-of-month processing within a defined time, then testing should gather evidence related to those expectations. Without that connection, test results can become vague and misleading because teams may celebrate that screens load and buttons work while missing the fact that an essential control or business process is broken. From an audit perspective, one of the most important questions is whether the test cases trace back to requirements in a complete and meaningful way. This is important because missing requirements often become missing tests, and missing tests often become production incidents. Readiness improves when the organization can clearly show that the system was examined against the needs it was supposed to meet, not just against what the project team happened to remember. Testing environments matter more than many beginners expect because the quality of the evidence depends heavily on where and how the tests were performed. If testing takes place in an environment that is very different from the live production environment, then the results may not reflect what will happen after implementation. Differences in system configuration, network settings, user permissions, connected applications, or data volume can all create surprises once the system goes live. That is why organizations try to make test environments representative enough to produce meaningful outcomes, even if they are not exact copies in every detail. Test data also matters, because a system may appear stable when using neat, simple, incomplete sample data, but fail when confronted with messy records, exceptions, duplicates, or unusual transaction timing. A beginner-friendly example is a checkout line at a store that works perfectly with one item and exact payment, but breaks when a customer applies a discount, returns merchandise, or mixes payment methods. Real businesses are full of exceptions, and good testing tries to reflect that reality before the first live transaction exposes the weakness. Readiness is not just about whether the software works. It is also about whether people are prepared to operate, support, and govern the system after implementation. Users need to understand their responsibilities. Managers need visibility into new processes, and support teams need clear procedures for incidents, escalations, and routine maintenance. Documentation is part of this preparation because undocumented knowledge tends to stay in the heads of a few project members, which creates operational risk as soon as those people become unavailable. Training also matters because a technically sound system can still create errors if the people using it misunderstand new workflows, approvals, or data entry expectations. For auditors, this area is important because weak training and poor documentation often lead to control breakdowns that are blamed on the system even when the deeper issue is lack of operational readiness. A new system should arrive with enough knowledge transfer that daily operations can continue steadily without constant rescue by the project team. When that transfer has not occurred, the organization may be implementing software, but it is not really implementing capability. Controls deserve special attention because CISA is concerned not only with whether systems function, but whether they function in a controlled, trustworthy, and auditable way. During implementation testing, organizations should verify that access controls, logging, approvals, data validation, segregation of duties, and exception handling operate as designed. These are not side issues added after the main work is complete. In many cases, they are essential to the business's ability to rely on the system, satisfy governance expectations, and reduce the likelihood of fraud, error, or abuse. Beginners sometimes imagine controls as obstacles that slow projects down, but it is more accurate to see them as guardrails that keep a functioning system from becoming a dangerous one. A process that moves quickly but allows unauthorized changes, weak audit trails, or inaccurate data may be efficient in appearance and harmful in practice. That is why readiness includes the successful operation of controls, not merely the visible completion of business tasks. User acceptance testing often becomes one of the most visible and most misunderstood parts of implementation testing. At a basic level, this phase allows business users to confirm that the system supports real operational needs and that important processes can be completed in a practical way. It is not meant to replace all earlier testing, and it should not be the first time the business sees the system in a serious manner. Instead, It serves as a meaningful checkpoint where business stakeholders validate that the delivered result is usable, understandable, and aligned with expected outcomes. Problems arise when user acceptance testing is rushed, delegated to people without enough process knowledge, or treated as a ceremonial sign-off rather than a genuine review. If users do not test realistic scenarios, or if pressure to meet a deadline discourages them from reporting issues, the organization may receive formal approval without real readiness. An auditor examining this area would care about who participated, what scenarios were tested, how results were documented, and whether unresolved issues were tracked before the decision to implement was made. Defect management is another important concept because testing almost always reveals issues, and the key question is how the organization responds to them. Not every defect has the same importance. Some are minor display problems, some affect convenience, and some threaten financial accuracy, security, legal compliance, or business continuity. A mature implementation process identifies defects, evaluates their severity, assigns responsibility, tracks remediation, retests the fix, and records whether any known issues remain at go-live. For beginners, it helps to think of a defect log as a disciplined memory for the project, preventing teams from relying on informal conversations and wishful thinking. The real danger is not that defects exist, because nearly all projects encounter them. The danger is that defects are misunderstood, hidden, poorly prioritized, or accepted without clear risk ownership. Readiness is weakened when a go-live decision is based on optimism instead of evidence, especially when serious unresolved defects are treated as future cleanup rather than present risk. Good implementation testing produces findings, and good readiness assessment interprets those findings honestly. The decision to move into production is often called a go-live decision, and it should be based on more than schedule pressure or executive enthusiasm. A system may be near the planned date, consume a large budget, and have strong sponsorship, yet still be unready for dependable operation. That is why organizations often use readiness criteria or go-live criteria, which define the conditions that must be met before implementation proceeds. These may include completed testing, acceptable defect status, approved documentation, trained users, configured access, support readiness, backup procedures, and management sign-off. The key idea is that a go-live decision should be governed, not improvised. Beginners sometimes assume that once testing is mostly done, implementation naturally follows, but strong governance recognizes that mostly done is not the same as ready. An auditor would want to see whether the decision process was formal, whether exceptions were documented, and whether risk acceptance was clear. When organizations skip these disciplines, the real launch criterion becomes hope, and hope is never a control. Operational readiness extends the discussion beyond launch day and asks whether the organization can sustain the system after the project team steps back. This includes monitoring, incident handling, backup and recovery, change control, routine maintenance, vendor support, capacity planning, and service desk preparation. A system can be technically implemented and still create chaos if no one knows how to respond when jobs fail, performance slows, or users begin reporting unexpected behavior. That is why implementation testing may also include scenarios related to restart, recovery, error handling, and support escalation. A useful analogy is opening a new building where the doors work and the lights turn on, but no one has checked the fire procedures, maintenance plans, or emergency contact process. The building exists, but it is not fully ready for safe, steady use. In the same way, a production system needs more than successful primary functions. It needs an operating model around it, so that normal issues can be absorbed without damaging the business. Security and resilience should be considered before go-live rather than after the first incident. Even when a system is not primarily a security product, it still processes data, supports decisions, and can become a path for disruption if weaknesses are overlooked. Implementation testing should therefore consider whether authentication works as intended, whether sensitive data is protected appropriately, whether logging supports investigation, and whether the system behaves safely under stress or error conditions. Depending on the situation, resilience may also involve backup validation, recovery capability, and the ability to continue critical services during component failure or unexpected events. For new learners, This is a reminder that readiness is not just about success under ideal conditions. It is also about survivability when conditions become difficult or abnormal. A system that performs beautifully on a quiet morning but fails during peak demand, a network interruption, or a bad input record is not as ready as it first appears. Auditors pay attention to this because real business environments are never perfectly calm for long. From an audit perspective, the focus is not on writing code or managing every detail of the project. The focus is on evaluating whether controls around readiness and testing are adequate, whether evidence supports management's conclusions, and whether risks were identified and handled in a reasonable way. An auditor may review requirement traceability, test plans, test results, defect reports, approvals, migration readiness, access setup, and documentation of exceptions. The auditor is trying to determine whether the implementation process was controlled enough to reduce the chance of significant failure. This does not mean expecting perfection or demanding zero defects, because that is rarely realistic. It means asking whether the organization understood what could go wrong, tested important areas, addressed major issues, and made an informed decision supported by evidence. For a CISA learner, this viewpoint is important because the exam often emphasizes governance, evidence, risk, and control effectiveness rather than deep technical construction details. The system matters, but the discipline around implementation matters just as much. A helpful way to tie all of this together is to see system readiness and implementation testing as part of a broader promise between technology and the business. The business is trusting that the new system will support operations, protect information, and avoid creating unnecessary disruption. Testing is one way the organization checks whether that promise is likely to be kept, while readiness reflects whether the surrounding conditions are in place to make success sustainable. When those areas are handled well, Go Live becomes a managed transition instead of a leap into uncertainty. When they are handled poorly, even a system that looked good on paper can trigger confusion, errors, downtime, and loss of confidence. For exam preparation, remember the central theme that readiness is multidimensional and testing is evidence-based. A CISA mindset does not stop at asking whether the system works. It keeps asking whether the system, the controls, the people, and the support model are all prepared well enough for real business use, because that is what responsible implementation truly requires.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.